we're going to go ahead and get started. We have a very special guest joining us today, which we are very excited about. His name is Luis Arizmendi, and he is a Principal Specialist Solution Architect at Red Hat. And he is joining, as usual, Avassa's very own Senior Solution Architect, Fredrik Johnson. And today we are here to talk about bootable containers at the edge. What, why, and how. We have a lot to learn today, so we better get started. And as usual, if you have any questions for our experts, feel free to post them in the chat or send them directly to me, and we'll cover them either as we go along during the session, or we'll make sure to cover them all at the end. And with that, I'm going to hand over to you, Fredrik.
Thank you. So first, welcome, Luis. I'm really excited to have you.
Thank you for inviting me.
So we have an agenda for today. Luis is gonna hit it off by explaining what is bootc and what can it do for us. Then it's gonna head it back to me, and I'm gonna talk a little bit about what I did to prepare for the demo, and then because I think that is as interesting as the demo in itself, to be honest. Then we're gonna run a demo and hopefully have a bunch of questions at the end. So with that, I'm actually gonna hand it over to you, Luis, to give an introduction and tell us about bootc and what it is.
Sure, yeah. Well, bootc is just a small part of what we use when we try to use bootable containers as part of our OS distribution. So if you don't mind, I will explain first what is a bootable container, right?
Yeah, so that sounds like a good start.
Okay. So you know that a container is a set of files and binaries and a process that runs in isolation in a system, right? So you can run multiple containers isolated one from each other in the same host. But still, they have to rely on a shared component. They share something among all others, which is the kernel host.
Yeah.
Regular container do not contain a kernel. It is not in the image, right? And that's the main difference, or the big difference with the bootable containers. In the bootable containers, we have the kernel inside these container image. And that's why they are called bootable, because in order to boot something, you need the whole operating system, including the kernel. Okay. So maybe you're thinking about, okay, why is this interesting for us? How we can use it? Yeah,
that was my question, because
that's a recurring question. Yeah.
Yeah, I mean, not having the kernel in the containers is certainly good in certain cases, just because you can make them really small. So therefore, I'm very interested in why would you want to have the kernel in the container?
Well, you can have several use cases for the bootable containers, but for the one that we will be talking about today is about how we can use. So in the bootable container, you have the full operating system, as we said, right? So the idea is, what if we get that container image, that bootable container image, and we use it to distribute the OS images? So instead of using iSource or PXE-boot images or something like that, we use a container image. Why that could make sense? Mainly because of three reasons. We have, for example, you know that there are a lot of customers that are putting more efforts on their tooling around the containers to speed up the DevOps. So we can use the same tooling and with the same knowledge to create also, with the same people, to create also the OS images, not only the containerized workloads images. That also gives you some savings, and you are getting a lot of features that you used to have with the containers that you didn't have while you are creating the OS images, right?
Yeah.
So the second one is that you also have a more, let's call it, simplified security. Why? Because we are using immutable image, and also in that immutable image could be signed, as we are doing, for example, with containers, which is much more simpler than with other distributed methods. Think about that. Even some of the container image registries already have some features that helps signing the container images that you have in there, right?
Yeah.
And the third one is quite interesting because it's trying to some kind of a speed up the integration with the partners or the ecosystem. Why? Because as you know, when you're using a container, you're building your container on top of a base, right? So imagine that I'm a partner, that I'm building an embedded solution, or a hardware partner that I'm trying to resell my hardware with the OS container on my hardware, right? I need to customize that image that is provided, for example, from Red Hat, right? Today, you have to develop a lot of things to make it work together and you ship it, right? But with this approach, you just have to do a simple customization on top of a base that is provided by us, by Red Hat, which also you have a better split in responsibilities, or where my customization starts and what is providing the vendor right here.
So would it be fair to say that, so my take from what you just said was that if I have a specific, like I don't know if BSP is the right word, like a board support package, but I have a special hardware. I went through a lot of hoops to get Red Hat on that, so it can help with that. But I'm also thinking, if I have a data center where I want to run RHEL exactly the same in 100 instances, this would also help me, right?
Exactly.
Yeah.
The consistency is also a good opportunity with bootc, but it's more related to because we are using an image. You know that right now we are also providing RHEL as an image using OS3. OS3, we can go into the details in just
sure.
but we also we already have that way of deploying RHEL at this moment. But the big difference is using these container images to distribute all the OS across the entire infrastructure.
Cool.
So I don't know if you want to go into the details. I have a couple of slides. I don't know if you
yeah.
if you don't mind.
Exactly. So that was being
Because
my
I think it's better to visualize what we are talking about. Sometimes when we start, let me know if you see my screen now.
Oh yeah, see it.
So remember what we said. We have in a single image, bootable container image, we have the whole operating system, the full operating system. We have the embed containers, embed applications, all the system binaries, and the kernel. But I was not 100% technically accurate here when I said that you can just directly use the bootable container to deploy a VM or a physical server, right? Because there are several pieces that you still need to develop. And that's where Red Hat and the open source community is working right now. First, you have a way to manage the images. So the operating system working as images. And as we already said, we already have that piece, which is OS3. For those that don't know OS3, OS3 is like Git-like content management for the operating system binaries. So you can deploy an operating system image, you have an upgrade, then you deploy a new image instead of just upgrading all the packages. So the same behavior that we have with our smartphones. So where you have an upgrade, you download the differences, reboot your smartphone, and poof, you have the new version there. So the same approach with the OS. That's managed by the OS3 piece. We also need a piece that manages how to pull the container image and how to apply the content of that image into the operating system. And that's bootc, what you ask about. What is bootc?
Yeah.
bootc is that piece that manages the pooling of the image, gets the content, for example, the OS3 image that is inside, and applies it into the OS. The third piece of that four pieces that we were talking about is when you deploy on top of physical hardware, you still need this bootloader, right?
Yeah.
And there is a special bootloader that is required here because we need to split that bootloader from the OS, because the OS will be completely outside of the hardware here. So this is a special piece that we also have to have here. And the last one is when you start from scratch. So you have an empty hardware, or you have to create a VM from scratch. You still need a way to create asset something that triggers that upgrade. For example, an ISO and BMDK or QCOW, we still need this builder machine. And that's something that we will review today, right? In the demo.
Yes, absolutely. So you build your container image, and we'll look at that more in detail. And then you is it fair to you convert that into an ISO or a VMDK or a QCOW?
Yeah, it's built.
Yeah.
You have a source, which is the bootable container image, and you transform it into a ISO or QCOW. Yeah.
Cool. Okay, so I'll explain a little bit on what I did to prepare for this demo. So actually, in my basement, I have a physical machine, an on-logic box, where I'm actually running this. So what I did was I created a container file, and don't worry, we'll look at this one in detail shortly. But I created a container file including the Edge Enforcer, because we think that is important to Avassa's customers. We do get a lot of questions on how do I provision my hardware, including the Edge Enforcer. And this just turned out to be a really simple way of doing that. And then, as Luis said, I built the image, and I actually created an ISO that I flashed onto a USB stick and pushed that USB stick into the machine, rebooted, and it just installed everything, and up it came. So that's what I'm trying to say with this picture. And the last thing I want to say is that
just one comment, which is also important, is that when we deploy, we have all these edge computing use cases where we don't have specialized personnel, right? And when you are deploying, right? So we made the deployment so easy, or we are trying to do always zero-touch provisioning. And that's also possible with this approach, because sometimes people say, okay, well, I have this distribution method, but then I have to do my own automation, or it could be complicated to onboard the device, but it's not, right? So we still have those automations in place here.
Yeah, no, I mean, this was truly zero touch. I was kind of expecting to have to do something, but it really just installed and rebooted, and up came RHEL basically on that machine. But what I also want to mention is that our customers know this, but Avassa has the Avassa Control Tower has a built-in image registry. So as part of this image build, I simply pushed that container image into the Avassa Control Tower. And that is what we do all day long. I mean, we distribute containerized applications. But that's also really nice, because that means that what we'll show in the demo, for some of our customers, it's really important to know that their edge devices, that the only thing that it communicates with for everything is the Avassa Control Tower. So for the applications that we distribute, that is not a problem. Those always come from the control tower. But with this setup, all of a sudden, now you can also get OS upgrades through the control tower, through bootable containers and bootc, which is what I'll show in the demo now.
Yeah, it looks nice, right?
It does. So let me share my screen.
So when you push the image into your controller, your control tower, your registry, it's just a simple push, right? It's like any other container push that you Podman push or Docker push.
Yeah, absolutely. So basically I did a Podman build and a Podman push for this. So I thought we start here, and can you talk a little bit about what we actually see here, Luis?
Sure. Yeah, this is quite so it's fairly easy to explain, because as you can see here, this is a container file, right? A Docker file. Everything looks familiar here. Maybe we can comment on the first line on the from. As you can see here, we are starting from RHEL bootc 9.4, right? This is the base image. Remember when we were discussing about using the base and put your customizations on top? This is the base. This is what, in this case, is provided by Red Hat. what is that bootc image? It is actually a RHEL 9.4 with this bootc component installed. That's more or less all, right? Then, as you can see here, the next step is installing packages. Even though we are using images, of course, we have to install packages at some point in time, right? So we are installing in here when we create the container. And this is something that we have to bear in mind. You can use this bootc and bootable containers approach with Fedora, CentOS, but also with RHEL. If you are using Fedora, for example, you can just perform this build in your own laptop, okay? But what happens if you want to install packages from the Red Hat binaries? Then you need a subscription, right?
Yep.
So that's why we encourage people to use or to run the builds on subscribed RHEL machines, because that's the easiest way to have access to these packages and to include the subscription when you're building the image. There are other ways to include your subscription if you're running, for example, in your laptop with Fedora or whatever, but we really encourage to run the builds on a RHEL system, subscribed RHEL system. And the rest is just, as you can see here, create users, copy files, and just run some commands with systemd.
Exactly. Yeah, I mean, the end here is really just to install our stuff on it, basically the Edge Enforcer. Again, I think this is pretty nice. It's really nice, actually.
This is something important is that here we are embedding some files, right? So we can embed applications, but we can also embed containers, which is some kind of crazy. So we are embedding container images inside the container, right? But that's useful because imagine that when you have to deploy on disconnected environments, if you want to keep that zero-touch provisioning where you deploy the operating system, but also the workloads at once, you still need access to those container images that you will be running in your system. If you are in a small disconnected environment where you don't have access to a registry, then you must include the container images inside that OS image.
Makes sense. Otherwise, we assume you're going to use Avassa to distribute container images.
No, of course. Of course. No, but we need to take care of all corner cases, you know.
Very cool. So I'm going to press on here, and I'm going to just briefly show you what this looks like in the control tower. So if you go into our control tower, you can see I'm running a bunch of applications here, but this is actually the container image that I pushed in, the bootc image. It looks like, to our system, it's just another container image. And I briefly just want to show you, so I call this the basement carbon because it's a carbon 400 that sits in my basement. So this is actually the hardware box that I installed. So you can see that this is an on-logic box that is running the Edge Enforcer, basically. And this is not super interesting for everyone, but what is interesting now is I'm actually going to go to this machine. So there will be a couple of going around the terminal here. But this is actually an SSH into that particular machine. And since I know we are running version 1, so what I did was I running the bootc command and doing an upgrade check. And what this does, to my understanding at least, is it goes to my control tower, the registry, and it checks if there is an update there. And at the moment, there isn't. But here's the thing. So Luis told me that, oops, if I can click the right button, that, hey, 9.4 is actually an old version. You should really be running on RHEL 9.5. That's the latest version. So what I did, and you're going to notice that when I switched to my second version on my container file, the only thing that changed is 9.5. And I can't stress enough, I think, that we're basically building a new container, ripping out the entire underlying operating system from 9.4 to 9.5. it's a simple change to change the 4 to a 5 in a file, but think about what actually means on this machine.
And it's more than that, because it's not only between minor versions, but it also works between major versions. So, for example, we also had this conversation with a customer that was trying to, in the past, trying to upgrade from 8 to 9. And we saw at that moment in time the OS3 approach, which is also based on images, and they were impressed because it's just a matter of rebooting and you have the new version there.
Yeah, it's just amazing. So what I'll do now is I'm go down to my RHEL machine here, and I'm gonna run this build containers version 2. So I just have a script that runs the Podman stuff. And you can see it. I've TV chefed this a little bit just to save time, but basically I'm running the Podman build, and then I'm doing a Podman push into the control tower again. And what's really cool here now is if I go back up here to the actual machine, I'm going to zoom in on that and run upgrade check, it will actually notice that there is a new version of the container image there. And as you can see, there are quite a few changes to this one just because we changed the base layer. But I'm actually going to do upgrade, apply. And please feel free to add stuff here, Luis, if I'm missing something. But this will actually tell the system, go fetch everything and apply it to the system.
Yeah, exactly. So now maybe it takes some time because this is something that we are working on to not having to pull. We want to only to get the differences, the deltas, right? So right now we are working exactly on this, trying to not getting that much information out from the registry, but only the deltas, as we are doing already with the OS3 approach.
Yeah,
okay, it's already done.
Yeah, that's really cool. But now you can see that it actually downloaded the new one, and now I lost the connection to the box. So it's gonna take maybe, I don't know, 30 seconds, a minute for it to come back, because it actually downloaded that. And am I correct? It's gonna install the new version on a new partition, right? And then boot into that.
Well, actually, being technically accurate is not a partition. It's just you know the CH root, right? That you have a whole system in a file, a whole operating system in a file system. So we have multiple CH roots and like a pointer, right? So it's pointing to one CH root, then you change to another CH root. That's why it's so simple to switch back. For example, if you want to roll back, it's just changing the pointer, restart, and you have the old version again.
Can you talk? I mean, I can show you later how you do a manual rollback, but can you talk just a little bit on in what cases would the system automatically roll back?
Yeah. So we include a feature that is called Green Boot, where you can develop your own health checks. So imagine that I'm deploying an application and I want to be sure, 100% sure that it's working when I upgrade. So you perform the upgrade, your health checks run, and if they fail 3 times, then they automatically roll back to the previous version. So I have a one case that the SSH stopped working when you upgrade from 8 to 9 if you were using all ciphers, because with the old ciphers were removed in version 9. So SSH stopped working for some customers. But in this case, when some customers that didn't apply the upgrades, of course, the configuration, SSH configuration upgrades. Then with this approach, when you have you upgrade, your health checks can check that you don't have SSH connection. Then roll back and you keep that connectivity. Because imagine that what happens if you have, I don't know, 100 devices across multiple places, you upgrade and you lose SSH connectivity to all of them. Could be a nightmare, right?
Yeah, so, yeah. Absolutely. Cool. But so now I'm actually back into it, and I think the easiest way of showing this is actually looking here. And Now you can see we're actually running 9.5, and just briefly want to go back into our UI. You can actually see that the site is reconnected to the control tower. We're up and running. The application that I was running there is up and running. So I honestly, this is just mind-blowing. And had we had more time, I would actually talk a bit about, because this wasn't like I didn't arrive at that exact container file immediately. It took me a while to develop that, to get the Wi-Fi working and all that. But it was so nice. I just added stuff, ran
was-
bootc. Yeah. And
Was simpler than expected, right?
absolutely.
Yeah.
Absolutely. Really cool. Really cool. Awesome.
So can I jump in with a couple of questions?
Absolutely.
That is great. So a question for Luis, I would say. When will RHEL image mode with bootc will be generally available for end users?
Well, right now, as you can see, you can use it, but it's only technical preview. We expect to have it in GA around Red Hat Summit time later this year, so RHEL 9.6, next release.
Very cool. And Red Hat Summit is in May, right? So that's
Yeah, something
coming up
like that.
close. Yeah, that's awesome.
Okay, right around the corner.
Also a question for Luis. Can I migrate a system from package RHEL to image mode?
Sadly, you cannot. So this is a complete new way of distributing the OS. So you have to deploy from scratch using this modality.
Package RHEL, is that like quote unquote like normal Red?
Yeah, the regular RHEL where you
Yeah.
have to install packages.
Yeah. Cool.
Cool. Frederick, question for you. How is bootc relevant for a typical Avassa customer?
Yeah, I think as I said in the beginning there, our customers, every one of them has distributed computers. So hundreds or thousands of locations where they run an operating system and they run Avassa on top, and then applications on top of that. And keeping the operating system up to date is a challenge for many of them. And having this method of being able to simply describe what your operating system should look like, having a simple way of distributing that through a container registry, maybe our container registry, and on top of that, get transactional updates, meaning if you, like Luis said, if you happen to get something into the new version that doesn't work, of having a way of telling the system, in those cases, we want you to automatically roll back.
And when you say updates, then you're talking about the operating system updates.
Yes,
Yeah.
operating system upgrades. Maybe there are certain packages that needs to be on the system that needs to be upgraded. And to be able to do that in a controlled fashion, I think also will. There are security vulnerabilities that are continuously fixed. I think this will help those customers keep, dare to get those fixes out much quicker, basically.
Cool, thank you. Luis, got another one for you. How does RHEL-based compare to the RHEL image mode? Does it have any drawbacks, any obvious upsides?
Yeah, well, we always try to push the benefits, right? But you also have trade-offs. At this moment, when you are using image-based RHEL, no matter if just with OS3 or with this bootc approach, you have to reboot, as you have seen, and you apply the new image by rebooting the machine. That's something that you can live with, depending on the use case. Imagine that you have a device, a lot of edge devices that you don't mind if they are rebooting overnight, right?
Yeah.
But there are other use cases where you need to be running 24/7, right? So that could be a challenge, but we are working on that. So hopefully in the future we have a way to apply changes without rebooting. But bear in mind that if there is a kernel upgrade, you have to reboot, no matter if it's a package base or image base, that needs a reboot.
Yeah.
That's a fair point. I think I'm going to squeeze in a final question, even though I know we're running out of time. Also for Luis, how can you automate rel image mode builds?
Well, those are container builds, right? So you can automate it with the same tooling that you have. If you have I don't know, a pipeline that is building your container images, you can use that pipeline. If you are using scripts, it's okay. If you are doing it manually, also good.
Cool.
It is very cool, but
Yes.
unfortunately we are out of time. So we're going to have to wrap it up. I want to thank you, Luis, so much for joining us.
Thanks to you for inviting me. I really appreciate it.
So I'm going to use the last moments of this session to, again, thank Luis and Frederick, of course, as usual, for this month's Ask the Expert session. And I want to do a little bit of promotion for April. We're back again, and that time we're going to do a session together with Plainsight on cost-effective edge AI. So that is not to be missed. And as usual, you sign up on the regular landing page. So we hope to see you then. But for today, we say thank you.
Thank you.
Thank you.